Hello and welcome back to Beyond the Business. Today's mini episode is not about climate targets or policies or sustainability slogans. It's about signals. Not opinions, not narratives, and no future scenarios. Signals that are already happening, measured by satellites, oceans, and the atmosphere itself. So, what we will talk about today is simple but uncomfortable. The planet is not waiting for consensus, it's already responding. Let's talk about what the signals are, where they come from, and why they matter far beyond weather headlines. Let's start with La Niña. The name itself comes from Spanish, La Niña, the little girl. It was originally used by fishermen along the coast of South America centuries ago. They noticed that around Christmas, ocean temperatures sometimes changed. Fish disappeared and weather patterns shifted. This wasn't a theory, it was an observation. Much later, scientists understood what was happening. La Nina is a part of natural oscillation between the ocean and the atmosphere in the Pacific, linked to changes in wind strength, sea surface temperatures, and pressure systems. Today, according to the World Meteorological Organization, there is a 55% probability of a weak La Nina developing this winter. And this is where misunderstanding begins. La Nina does not cancel climate change. It does not cool the planet back to normal. What it does is redistribute energy. Rainfall shifts, storm tracks move, some regions experience floods, other prolonged droughts. And here is the critical point. La Nina now operates on top of a warmer baseline. The ocean is warmer than it used to be. The atmosphere holds more energy than it did decades ago. So even a cooling phase behaves differently than it once did. This is not reversal, it's a modulation. Now let's move from Pacific to the oceans as a whole. Satellite data from Copernicus Sentinel-6 shows something important. Sea level rise is not uniform. It's not just water going up. It's thermal expansion, ice melt from Greenland to Antarctica, change in ocean circulation. In the North Atlantic, this matters enormously. The Gulf Stream, a massive ocean current, acts like a climate regulator. It transports heat from the tropics towards Europe, shaping weather across the Atlantic basin. When ocean temperatures change and fresh water from melting ice enters the system, circulation dynamics shift. This doesn't just affect coastlines. It affects storm intensity in the Atlantic, winter temperatures in Europe, precipitation patterns in West Africa, and even monsoon behavior further east. This is why climate change cannot be reduced just to global average temperature. It's a system response, not a single metric. The third signal comes from the sky. Atmospheric rivers. These are physical phenomena, long, narrow corridors of moisture transporting enormous amounts of water vapor across oceans. NASA satellite data shows these moisture flows become stronger and more frequent. But why? Because warmer air holds more moisture. That's basic physics. As the atmosphere warms, it becomes a more powerful transport system. When these moisture corridors hit land, whether in North America, South Asia, or parts of Europe, the result can be extreme rainfall, flooding, landslides, and infrastructure stress. This isn't random weather, it's energy being released. And it doesn't stop at the US Pacific Northwest. Similar dynamics affect South and Southeast Asia through intensified monsoon systems, East Africa through irregular rainfall cycles, parts of Europe through stronger winter storms and summer extremes. Different regions, same underlying driver. So, what connects La Nina, sea level changes, ocean circulation, and atmospheric rivers? The answer is simple, it's an energy imbalance. The climate system is not breaking apart, it's reorganizing. Ocean atmosphere, winds, and moisture are adjusting together. This matters because these adjustments affect food production, water availability, infrastructure resilience, insurance systems, and economic stability. Science cannot tell us the exact moment of the tipping point, but it can tell us this. Many systems are operating close to known limits. Uncertainty doesn't mean safety, it means risk. What we discussed today are not abstract models, they are signals already visible in the oceans, storms, and seasonal shifts. If we continue to treat climate change as a debate, a preference, or a communication challenge, we miss what's actually happening. The planet is not asking for agreement, it is responding to accumulated energy. Understanding climate as a system means learning to read signals, not waiting for perfect certainty. Because systems don't wait for narratives, they respond to physics. Thank you for listening to Beyond the Business. Let's keep reading the signals before the system forces the response.